All right, let's spend a little bit more time on lists and in particular looping constructs and lists. So let's start with a little exercise. Remember that in a list, I can store any elements, numbers, floats, strings, lists. So this is a list of lists. So look at these commas here. We've got the big square brackets on the outside. I have one element right here, comma. I have another element right here, comma, and I have a third element here. So this is the 0th, 1st, 2nd. The 0th element and the 1st and the 2nd are each lists, each with 3 elements each. Okay? So this is a two-dimensional list. You can think about these as sort of rows and columns. So this is the rows of and then 1, 2, 3 rows, and then these are the columns just sort of sandwiched into this linear thing. Okay? So think about it sort of like if I had a square, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And the reason I'm going to do that, we're going to do a little drill with a checkerboard in a little bit. So I want to get you to start thinking about these as two-dimensional. Okay? So let's say I ask you to add 1 to each element of each sub-list. So this is the list, that's a sublist, sublist, sublist. So what I want as the output is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So let's think about how we would do that. So we know we've got to iterate through each one of these lists. Okay, so let's write that first for loop right here. For I in range, 0, len L. Remember, len will tell me the length of the list. The length of this list is 3. Range 0, 3 will give me the number 0, 1, 2, right? Not that last element. So that's good. I get 0, 1, 2. And what is this little line of code? It says, please add to L sub I plus 1. So let's see if that makes sense. Well, what is L sub 0? It's the entire list, 1, 2, 3. So does this make sense? Add a list to a number. No, that doesn't make sense. I can only add 2 numbers or 2 strings or a float and a number. But I certainly can't have this be a list and this be a number because L sub I is that entire list. So that's not quite right. So let's scratch that. Okay. So what do I want to do? I still want to go through each element of the list, but once I'm here, I've got to tap now into each element of the sublist. Yeah, so I've got to tap in and grab the 1, grab the 2, grab the 3, and then on the next iteration, grab the 4, grab the 5, and grab the 6, and so on and so forth. All right, so let's see what that would look like. So do you remember what the notation is for this? It's that double square bracket. Grab the 0th element of L, square bracket 0, and then grab the 0th element of that, another square bracket 0. So let's see what that looks like. Okay, so let's look at these 3 lines of code. L sub I, so forget everything else for a second. What is L sub I? I is 0, so L sub I is that entire sublist. It is itself a list. And now I'm tapping into the 0th element right there, which of course is 1. So I'm saying L sub 0 sub 0, that's 1, equals L sub I sub 0 plus 1. Good. What is L sub I sub 0? It's a number. A number plus a number is a number, and I shove it in right there. So that line of code looks good. And then what am I doing? I'm just grabbing the next element and the next element. And since each of these has 3 elements, this works beautifully. Okay? Now, so this is all fine and good, and this seems to work, and it's just a reminder of how we do this double indexing. But what happens if my list of lists looks like this? So this list has 2 elements, this list has 3 elements, and this list has 4 elements. What's going to happen in this line of code? Well, it'll be perfectly fine here, 3 elements. It'll be broken here because the 9 doesn't get incremented by 1. And it's really broken here because there is no L sub 0 sub 2. There's only L sub 0, that list, sub 0 sub 1, and there is no 2. So that this piece of code assumes I have the same number of elements in each sublist. That'd be great if it does, but what if it doesn't? What do we do? So let's try to think about this solution. So that doesn't work for this variable number of solutions because either you have an error in overrun or you're not indexing through all of the lists. And no matter how you try to write this, you're going to have a problem. If you set this to 2, only 0, 1, well then you miss one here, you miss one here. If you set it to 4, then you have an error here and you have an error here. So there's really no finagling our way out of this. So conceptually, what do we want to do? Well, we sort of want to grab L sub I, this list, and then this one, and then this one, and ask, well, how many elements are in the list? And then iterate through those, yeah, in the same way that we're iterating through these, right? So conceptually, that's what we want. Now let's see how to do it. All right, so this line of code is still good. We know that we've got to tap into each sublist. So I is going to be 0, 1, 2. Good. But once I grab that list, I now don't know how many elements are in there, so I want to iterate over all the elements of the sublist. Well, how do I iterate? With a for loop. So we need another for loop. All right, let's see what that looks like. So first of all, notice that this for loop is in the body of this for loop. These are called nested for loops. So for I in range 0 to the length of L, 0, 1, 2. Good. For J, new variable of course, in the range of what? I want to know how many elements are in the sublist. The range of 0 to the length of, not L, but L sub I, where I is coming in from here. So on the first iteration, I is going to be 0. J is going to go from 0 to what? Well, that's going to be 2 because there's 2 elements in the list. So J will take on the value 0, 1. Good. Let's do the body, and then we'll loop back and see what's happening here. So what do I want the body to look like now? So at this point, notice, by the way, everything's indented. So this for loop is in the body of this for loop. This statement is in the body of this, which is in the body of the outer for loop. So at this point, I know I is 0. Good. And the first iteration, J is 0. Good. That's 1. So L sub 0 sub 0 is equal to L sub 0 sub 0 plus 1. Good. What happens when I finish this line of code? I have to finish this for loop, right? So forget about the for I loop for a second. I've got this little for loop here that's got to spin its way out. So we go back up. I is still 0. Nothing's changed. I'm inside of this body still. I'm just doing this little bit of code. I'm not back up here. So J will take on the value of 1. L sub 0 sub 1 is equal to L sub 0 sub 1 plus 1. That means that is going to become a 3. Now at this point, this for loop has exhausted itself. So where do I go next? Well, I go back up to the for loop that was above. So I was 0. Now it's going to be 1. Okay, now we go back in. Now what is the value of J? It starts all over again, right? So J now is going to go from 0 to the length of L sub 1. That's 3. 0, 1, 2. Now, L sub 1 sub 0 is equal to L sub 1 sub 0. L sub 1 sub 1, L sub 1 sub 2. We get out, we go back up, we do it again. So notice that these nested for loops, this bit of code here in the body gets done 3 times associated with this. Each time I go in here, I'm starting fresh, right? Once I execute this code and I come back up to the for loop and start again, I'm starting all over, right, with a new I. Good. So let's make sure we understand those nested for loops because we're going to need them for a drill in a second, and they come in super useful in a number of places. So let's go back to a single for loop. For I in range 0 to 5, 0, 1, 2, 3, 4, print I. So on every iteration of the body, I takes on the value 0, 1, 2, 3, 4. Done, right? Easy. While loop, for loop, all the same thing. We've done it a number of times, very easy. So just to make sure we understand nested for loops, let's play out this statement. So for I in range 0 to 5, for J in range 0 to 5. So I is going to take on the value of 0 to 5. Okay, listen carefully now. For every distinct value of I, 0, 1, 2, 3, 4, J will take on the value 0, 1, 2, 3, 4. For every value, right? Because what's going to happen here is I is 0. Okay, good. Execute the body, please. J is 0. Execute the body. Print IJ. That prints 0, 0. Where do I go from here? I'm inside of a for loop. The fact that I was up here, you can forget for now. I'm in this for loop. I've got to spin it out 4 more times. So print what? Go back up. J becomes 1. What is the value of I? Still 0, right? We're still in the first iteration of the I loop. So we print 0, 1. Okay, good. Where do we go from here? Back into the J. Increment J by 1. Good. 2, 3. Okay, let's do one more. 4. Okay? Now, I've exhausted 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. This internal for loop. I'm done. Where do I go from here? Well, I'm still up with I equals 0. So now what do I have to do? Well, I has to go to 1, and then what do? I start all over again. J goes 0, 1, 2, 3, 4. And then I go back up. What is I? 2. J is 0, 1, 2, 3, 4. What does this look like, by the way? It's an odometer. This is exactly an odometer. You take the far right bit, it goes from 0 to 9, and then you tick over. And then what do? You go from 0 to 9 again, and then you tick over. Those are nested for loops, right? They're counting this thing, and then when it loops, when it gets done, the next counter goes, and then you start all over again. So the way to read these things is always keep in mind, I have to evaluate this body for each value of I. I have to evaluate this body for each value of j. So follow those indentations very carefully. Okay. Good. All right, let's do a drill with nested for loops. Okay. So I'd like you to draw this 9 by 9 checkerboard with alternating red and blue squares. Now, obviously, you're going to use nested for loops, which is why I was giving this indication of two-dimensional. So what you want to do, and this is also a really good example, you got to spend some time thinking about how you're going to do this. But basically what you want to do is for every row of this canvas, you want to draw a red square, followed by a blue square, followed by a red, and you do that 9 times. Okay, so here's a good way of incrementally doing this drill. Start the drill by just drawing one row of this checkerboard. Okay, that's it. Just red, blue, red, blue, red, blue, red. What is that going to be? Well, almost certainly it's going to be a for loop. You could do it manually, but then if I change 9, 9 here, you're going to have to. So do it with a for loop for I equals 0 to in range 0 to 9, and then just toggle between red and blue. Think about how you're going to do that toggle. I'll give you a hint. You want a state variable to do that. And get the one line to go. Now, once you've got that, you can see that this dimension, doing every other row, is sort of the same thing, except you have to alternate, right? It has to be red, blue, red, blue, red, blue. So do the one line and then figure out how to do this with a nested for loops, and then draw the checkerboard. Okay, so this may take a little time. You got to think through a couple of the logics of the for loops rather, the nested for loops, and then the logic of how you flip between red and blue. So go ahead and pause the video, and I'll show you my video in a minute when you get back. Okay, see you in a bit. Okay, I hope you got that. And if not, that's okay. Just take a look at my solution and go back and try to do it again. All right, so let's just get through some of the boilerplate stuff. I'm going to import draw. I'm going to define a canvas. Mine is 200 by 200. I don't care how big you make these things. And I have a state variable here called c equals 1. This is going to control the color of the square, and I'll show you in a minute how I do that. So what is a two-dimensional checkerboard? It's got 9 rows, 9 columns rather, and 9 rows. And so what I want to do is just move left to right, top to bottom. So let's see. Left to right, what am I doing? I'm changing the x value associated with the square. So x goes from 0 to 100 or whatever it is. I don't care where you drew it. And then when I drop down, and y is say 0. And then when I drop down, y takes on a new value, and then x repeats its value. It sounds a lot like an odometer. And then I drop down again, y takes on a new value, x repeats itself. Yeah? So the x coordinate for every column is exactly the same regardless of what row it is. So this value of y is changing, this value of x is changing, and now we're going to embed that into a nested for loop. So let's see what we're doing. For y in range 0, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, nested inside of that is x in range 0 to 9. So x will go 0 to 9 when y is 0. Y will increment to 1, x will go 0 to 9. Y will increment to 2, x will go 0 to 9 until y goes to a value of 8. Okay, good. So inside of this nested for loop, I have all the pairs of xy coordinates that correspond to that two-dimensional checkerboard. Yeah? And now I've just got to draw and then change the colors. All right, so let's ignore the color change for a minute. Let's just look at these two commands are exactly the same except for the blue and the red here. So let's just go ahead and look at it. So what am I doing here? I'm drawing a rectangle, of course. And remember, these are the x coordinates and the y coordinates. And then this is how big the square is, so 20 by 20, and that's the fill color. Okay? And so all I'm doing is I'm taking the x coordinate, multiplying it by 20, and then subtracting 90. Okay, I'll explain what I'm doing there in a minute. And here what I'm doing is I'm taking the y value, multiplying it by 20, and subtracting 100. So let's make sure we understand what's going on here. When y is 0, what is this value? Minus 100. When y is 1, what is this value? Minus 80. Right? So now you can see what's going to happen. When y is 2, what is this? Minus 60. So I'm changing the y coordinate from the bottom to the top. When x is 0, what is this value? Minus 90. When x is 1, what is this value? Minus 70, minus 50, minus 40. So what I'm doing is I'm converting 0, 1, 2, 3, 4, 5, 6, 7, 8 to actual coordinates on the drawing canvas. Okay? So as I move x, I move this thing from left to right, and as I move y, I draw. You could have drawn top to bottom or bottom to top. It doesn't matter. Okay? And now all I have to do, so now what I've done is I've converted these integers into coordinates specified based on how big I wanted the checkerboard to be. And now all I have to do is toggle the color. So I start off with c equals 1. Inside this nested for loop, if c equals 1, I ask you to please draw in blue, and then look at what I do. I change the color to red. So that means the next time in the for loop I come down, c is 0. Notice there's an else clause here because I know it can only be 0 or 1, so I don't have to test equality to 0. And I draw red, and then I change my state variable c to be 1. Next time through, it's blue, and so on and so forth. And you can see what happens here is when I get to the end, I'm at some color, but since these get done over and over again, I'm not reinitializing this. When I go down to the next row, I flip the color as I want to flip. Okay? So I've got a little state variable here that flips every time I draw, and then I either draw blue or red. Okay? And then what I'm doing here is I'm converting these x, y numbers into coordinates, and then of course the magic here is the nested for loop. So again, on the first iteration, y is 0 and x, so that value is fixed in the first set of this inner for loop. So y is set equal to minus 100. That means I'm going to go along a row. X is going to modify, whoop, left to right, and then I'm done. I come out to the y value, I increment y by 1, and then I start x all over again, but y is now down 1 or up 1 in this particular case, and I go left to right. Again, 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 again. So you can see why I was referring this earlier to two-dimensional. All right, there's a bunch of stuff going on here, state variables, the drawing, of course, the conditionals, and the nested for loops. So let's make sure we understand those nested for loops. If you didn't get the drill, totally fine, but make sure you go back and you either understand that or you can actually regenerate that from scratch. All right, there's one more lecture on lists, and then we'll move on to a new topic, so I'll see you in a few minutes.